Ever wondered if you could hop into a machine, press a button, and travel through time? This question has sparked curiosity and fascination for centuries. The concept of time travel has been a captivating topic, deeply ingrained in our collective imagination, from H.G. Wells' novel, The Time Machine, to popular films like Back to the Future. This allure isn't just limited to the realm of fiction. Even in the scientific community, the idea of manipulating time has been a subject of intense debate and exploration. The possibility of stepping into the past to witness history unfold or venturing into the future to see the progress of humanity is, simply put, tantalizing. Yet, the concept of time travel isn't without its complications. Paradoxes arise, such as the infamous grandfather paradox, which challenges the very logic of our universe. While time travel remains a fascinating concept, is it just a figment of our imagination, or could it be a scientific possibility? Scene script. Enter Albert Einstein, the genius whose theories may just hold the key to understanding time travel. Albert Einstein, a name synonymous with brilliance, changed the course of scientific understanding with his special theory of relativity. This groundbreaking theory, proposed in the early 20th century, fundamentally altered our understanding of time, space, and the very fabric of the universe. Einstein's theory tells us that time is not absolute. Instead, it's relative and intertwined with the concept of space, forming a four-dimensional structure known as space-time. This suggests that time and space are not separate entities but rather different dimensions of the same reality. One of the most fascinating aspects of Einstein's theory is the concept of time dilation. Now, this may sound like something straight out of a science fiction novel, but it's a very real phenomenon supported by solid scientific evidence. Time dilation essentially states that time can be altered by speed. Imagine two clocks, one stationary on Earth and one aboard a spaceship traveling at a significant fraction of the speed of light. According to Einstein, the clock on the spaceship would tick slower than the one on Earth. The faster you move through space, the slower you move through time. This is not due to any mechanical failure in the clock or the effects of space travel on its mechanism. No, it's simply that time itself is running slower on the spaceship. Now, this doesn't mean we can hop in a fast car and zip around until we've traveled a few years into the future. The effects of time dilation only become significant at speeds close to the speed of light, far beyond what we can currently achieve. But it does mean that time is not the constant, unchanging entity we often perceive it to be. It's flexible, malleable, and under the right circumstances it might be manipulated. So according to Einstein, time is not constant but flexible, and under the right circumstances it might be manipulated. Let's delve deeper into the world of relativity and its implications on time travel. One of the most influential minds of the 20th century, Albert Einstein, proposed the general theory of relativity. This groundbreaking theory has reshaped our understanding of the universe, space, and of course time. But how does it connect to the concept of time travel? At the heart of Einstein's theory lies the idea that space and time are interconnected, forming a four-dimensional fabric known as space-time. Massive objects like planets or stars cause this fabric to curve, creating what we perceive as gravity. But here's the intriguing part. According to Einstein, the curvature of space-time by gravity affects not only the motion of objects but also the flow of time itself. This phenomenon is known as gravitational time dilation. Imagine a clock near a massive object, say a black hole. The closer the clock is to the black hole, the slower it ticks compared to a similar clock far away. This isn't because the clock is broken or affected by the black hole's immense gravity. No, the clock ticks slower because, according to general relativity, time itself runs slower near massive objects. Now let's bring this concept closer to home. The Earth, being a massive object, also causes time to run slightly slower compared to less massive objects. This has been tested and verified using accurate atomic clocks. When an atomic clock at sea level is compared to one at a higher altitude, the clock at sea level, closer to the mass of the Earth, runs slower. So, what does this mean for our astronauts orbiting the Earth? Well, being further from the Earth's mass, time for them ticks a tiny bit faster than for us on the ground. Over a year, an astronaut might age a few milliseconds less than someone on Earth. So, in a way, astronauts are indeed time travelers, aging slightly slower than us on Earth. Now, assuming time travel is possible, what paradoxes and predicaments could we encounter? Let's start with the grandfather paradox. It's a classic thought experiment that asks, what happens if you travel back in time and inadvertently prevent your grandparents from meeting? Would you simply cease to exist? Then there's the bootstrap paradox, another brain teaser that deals with objects or information that exist without any discernible origin. Imagine, for instance, you travel back in time and give a young Einstein the theory of relativity. Who then really discovered the theory? The many worlds interpretation offers a potential solution to these paradoxes. Essentially, it posits that every time travel event creates a new, separate timeline. So, if you did prevent your grandparents from meeting, you'd merely create a new timeline where you don't exist, but you'd still exist in your original timeline. While these paradoxes present intriguing challenges, they certainly add to the allure of time travel. So, after all is said and done, can we actually travel through time? Well, let's wrap up what we've discussed so far. Time travel, as we know it from science fiction, remains within the realm of theory and speculation. The theories of relativity, both special and general, do suggest that time is not as linear as our everyday experience would have us believe. In fact, they hint at the tantalizing possibility that time travel could, under certain conditions, be possible. Yet, it's not that simple. There are paradoxes and conundrums to consider. We've talked about the grandfather paradox, where a time traveler could potentially alter their own timeline, and the question of energy requirements, which are currently beyond our technological capabilities. In essence, while our understanding of physics suggests that time travel isn't entirely off the table, it is, to say the least, a complicated affair. Whether or not we'll ever be able to build a time machine remains to be seen, but until then, the concept of time travel will continue to captivate our minds and fuel our imagination.
Thank you so much for watching. If you enjoyed this video, don't forget to hit the like button and subscribe to MBuzz for more videos like this. Your support means the world to us. Until next time.